So in August 2021, GitHub experienced an outage where their MySQL database went into a degraded state. Upon investigation, they found out that it was due to an edge case. So how can an edge case in your business logic can take down an entire database? In this video, we understand what happened and take a fictional example, a total fictional example of how an edge case can put extra load onto the database. So let's jump right into it. So what I'll do is I'll start with the report. This is August 2021 site availability report for GitHub. And in this, what we'll look at is the first incident. So what it says that the incident was caused when one of our MySQL primaries entered into degraded state. So this was not a replica, but a master instance of primary, which means writes will be affected, right? So if the master goes down, because master is the one that is definitely taking in all the writes. So if master is affected, your writes will be affected. So if there is any application that is interacting with your master database right away, you need to be very careful that, hey, if that application is misbehaving with your database and your database goes down, you are directly impacting the master database, affecting a number of internal services. Internal services is fine, right? But this caused an impact to github.com services, which means an internal database that was handling writes got affected, which with a cascading effect took down the main github.com website. So if you see how even though you have microservices architecture, you would see how these components are linked to each other. An internal service or an internal database getting affected by some internal service, but main website getting affected. So that is a con, or that is a challenge of managing a distributed system. You never know when some random machine gets affected and it takes down your entire website. That's the beauty, but basically that's the beauty of basically running a massively scalable distributed system. You never know which machine going down takes your infrastructure with it. So which resulted in some users being unable to perform operations. Now these are end users like you and me. We are unable to perform operations because the master database was down because of some internal service. That's fine. So investigation had identified an edge case in one of our most active applications. So here the key thing is most active application. Sorry. So the most active applications that we talk about is when an application is most active, which means it is one application that is firing a large number of queries on your database. So if there is an edge case into something that is very frequently invoked, making a call onto the database, it has the potential of taking a database down or your application service down because it is most active. So if, let's say, some service queries a database once every hour, even if that is down, it would not impact much. But if something which is very high, which is very frequently querying your data, that's where if that goes down, it takes everybody with it. So we have to be very cautious that whenever we are writing a service that is very active or very frequently invoked, we cannot potentially bear the cost of an edge case in that. Right? So what it led to? So there was an edge case, agreed, but what it led to? It led to the creation or generation of poorly performing query capable of impacting the overall database capacity. This is pretty serious because one edge case is leading to creation of a poor SQL query, which is then fired onto the database, which means that whenever, and obviously we know that if our queries are not optimal, what would happen? If our queries are not optimal, your database will take large amount of time to execute it. It would continue to use its capacity, your RAM and CPU, to evaluate that under optimized query, which would take a large amount of time, which would put additional load onto the database. And because this application is a most active application, which means that the number of queries that it would fire will also be large. So a large number of unoptimized queries being fired onto the database, it would suddenly increase the CPU and the memory utilization of it, eventually taking it down. So with this, you'd say, but if that is there, what if I put a load onto the database, but database would eventually execute the query, right? Yes, but it would take time for database to do it. So it would be able to handle not large, but small number of queries, small number of concurrent queries, which would put in more load onto our API servers. It would do retries because it failed. And that would have massive impact onto your database because it is continuously getting bombarded by poor or unoptimized queries, which is putting unnecessary load onto it. Even here they mentioned that this combined with, like, even it generated poor performing queries, but this combined with application retry and queuing logic. So we always think retries and queuing logic are the way out to fix ourselves from the transient issue, but that would not work. Or rather, that works, but that would put in this case, more unnecessary load onto a database. Because let's say you wrote a query which is very poorly, or a query was generated which is very poorly performing. And let's say it takes 10 seconds for it, because of this poor performing query, it takes 10 seconds to execute. And let's say you have a retry logic, or you have a timeout of, let's say, 5 seconds. And after 5 seconds, you do a retry. So you short a query onto your database which takes 10 seconds to execute. You have a timeout of 5 seconds, and then you are doing retry. So that query gets executed in 10 seconds, but in 5 seconds you short another query because of your retry logic. So you are constant, and plus this is being an active application, it is bombarding a large number of queries onto the database, which means that your database is never getting a chance to automatically recover, which is the worst part. So if your database would have gotten a breathing space, it could have recovered on its own. But because of application retry logic, a large number of poor queries are getting fired onto your database just so that you thought that it would automatically fix your transient issue and get your things up and running. But poor performing queries firing continuously onto your database can take it down. Right? In this incident, the folks at GitHub did not mention anything about what exactly happened or how it happened, but this was the gist that they gave. It was an edge case that took down the database. So what I'll do now is we'll take a quick look into a fictional example on how an edge case can take down a database. Although we just talked about how there is an edge case which led to generation of poor performing queries, but can we take a almost real example which is very close to GitHub and see how it could have, it's purely fictional, how it could have done that, right? So what exactly happened is, whenever the request came in, it came to one of your API servers. This API server was generating a MySQL query required to be, which was getting fired onto this database. Sorry. So user your API request came in, API generated the MySQL query and it fired onto the database. If this resulted into a timeout, your API server automatically retried, right, as part of its retry logic. So here, what happened is we added retries to recover the transient issue, right? But it also led to shooting large number of queries onto your database. So while your database was already executing heavy queries, it got retries. It means it got large number of queries. So then your database never get a chance to recover, which means your database was constantly in a degraded state. So whenever an outage like this happens, you typically cut down all the writes, you give your database time to recover. And then once it is back up, you then again start moving requests to that. So now, again, a disclaimer, this is just an example, nothing to do with GitHub. I'm just trying to explain how an edge case can put huge amount of load onto a database. So say we have commits table. The main commits table in which whenever we commit to any repository, there should be one table that holds all the commit information. Right? So let's say we have a commits table in which we have ID, message, author ID, created at. The column created at is epoch milliseconds, which means it's stored as an integer. Right? And let's say for every user of GitHub, we are rendering a profile card like this, in which you have photo, name, some bio information, and 72 commits last week. So basic analytics in which we are showing users that, hey, you made 72 commits last week. Now this being a profile card of a user, this is very frequently fetched. It's most active, right? So now, whenever a profile is loaded of any user, whenever you hover on profile of any user, you get this information. Now what would happen? Now in order to render basic information, name, photo, bio is part of your authentication table. Like you can very quickly get it, or your profile table, you can very quickly get it. But in order to get the number of commits you made in last 7 days, what you have to do, this typically would come from your front end. Hypothetically, let's say the start date comes from your front end, so that you decouple your back end and your front end environment. So what you do is you fire a query. In order to aggregate or in order to count the number of commits you made, you fire a query like this. Select count ID from commits where author ID is equal to 1 to 3 and created at is greater than start date. This start date over here is an integer because created at is an epoch milliseconds column. And now let's assume that our service is written in Golang. It can happen with any language, but I'm just taking a very particular example of an edge case. So let's say our service is written in Golang and we get start date in the query parameter, right? So from your front end, you would get request something like this. https://api.github.com/stat/commits, and in query parameter we pass start date is equal to some epoch timestamp. So from this epoch timestamp, how many commits have been made, right? So for example, and why do we want to do that? Let's say on mobile screen, you would also want to plot the graph on how your commits have been over last 7 days. On desktop, you have larger space. So let's say you want to go for 30 days. On mobile, you have smaller space. Let's say you want to go for 7 days. Just hypothetical example. So that is why it is important to send start date as a query parameter. So now, if I write a Golang based code to solve this problem, what I would do is, because I'm getting start date in my query parameter, I would have to extract that. And start date, in any case, whenever we get a query parameter, they are all string, right? So what we have to do is we have to extract that query parameter, convert it into an integer, and then pass it into a SQL query, right? So what our code would typically look like is int start date. You define an integer variable called start date. You then try to convert your query parameter start date and store it into the start_date variable. And what Golang does is Golang gives you a function called a to I, which means string to integer. It gives you a function that converts a string to an integer. So if you give 1 as a string, it would generate 1 as an integer. If you give 100 as a string, it would give you 100 as an integer. So given that, you invoke this function and you have assumed that the input that you will get will always be an integer, or will always be will always look like an integer, right? So now what you do is you apply this function strconv.a2i and in bracket you pass in your query parameter that you got. So what Golang does is Golang does not generate exception. It returns an error. So it would return, the return value of this will be two values. The first value is the integer value, which is what we want, and second is the error value. Now you are pretty confident that hey, it's the front end who is sending me the request. Now the front end would always give me a correct integer to start with. It would give me the correct epoch timestamp to start with. So you just ignored the error. So what you wrote is you wrote start_date, comma underscore, which means you are ignoring the error, then colon equal to strconv.a2i, and in bracket you are passing the query parameter. And then you are using the start_date, which is now an integer, into your SQL query and trying to execute it. So when you do, you fire a query like this: select count ID from commits where author ID is equal to 1 to 3 and created at is greater than start date. The start date being an epoch millisecond, you are literally injecting this integer into this thing and basically trying to evaluate the query. Now what happens is, let's say there is an edge case where your front end did not pass the start date. If your front end did not pass the start date, or due to any reason your front end could not pass an integer value in the query parameter, let's say it passed in 1 hyphen, it was not a proper integer. Some bug happened, some release happened, some front end issue happened, or there was something wrong with the calendar widget, the version got upgraded, something weird happened. But because of which the start date that it is sending from the front end is either not passed, because of some backward compatibility front end issue, or is not an integer value. So then what would happen is, because of some misconfiguration, the value that you are getting is either not an integer or you are not even getting it. So now what would happen? Because your query parameter is not there, start underscore date, what would happen is your strconv.a2i will throw an error. But you did not handle that error because you ignored it. You thought that it would be proper. So then what happens in this case? Because you ignored the error, the default value of an integer will be used. So what's the default value of an integer in Golang? 0. So because now it is using the default value, the query that would be fired would look something like this. Select count id from commits where author id equal to 1 to 3 and created at is greater than 0. Your created at column is an integer which is storing epoch milliseconds, and now it is doing and created at is greater than 0, which means it is literally, for that person, it is literally going through all the commits and aggregating it. So this means that every time this query is invoked, it has to go through all the rows or all the commits made by the user ever and do a count of it. So that is extremely costly. Not just one execution, but coming in bulk, because this is a profile card. The request would come in very frequently. So when one of the most active applications is having an edge case which lets it to generate a poorly performing query, it would put unnecessary load onto your database. Right? Because this is an expensive query. It is continuously getting fired onto your database. You don't get a response in 5 seconds. So you retry. You retry again and again, this same query is being fired onto a database. The database takes large amount of time to do it. It does not get time to recover and puts it into a degraded state, eventually taking it down. So this means that unnecessary load is being put because of an edge case, right? So given this is a very common query, very frequent query, it will put a massive load onto a database. So this is a fictional example of an edge case which is generated. So now, what is a key takeaway from this? That whenever we are firing any query, or whenever we know that something is very actively, or some query will be very actively fired onto a database, no matter how confident you are, never miss out on any error, never ignore any error, never overlook an edge case. Assume everything that was given to you would be errored or would be weird. Like let's say you are right, or you are inserting a string. Have a limit on that. How big of a string can you insert onto your database? Don't just take in any input that is given to you. With integers also, do sanitization right before you invoke a query. Be as pessimistic as possible when writing application, so that you make your system, your process, your product foolproof. Otherwise, you'd never know when a weird thing happens or a backward compatibility issue happens in your front-end library, taking down your entire backend, or basically taking down your entire database, and eventually your paying customers getting affected. Right. So just a basic caution on how we should be thinking about building something or utilizing something without just actually putting in any thought. Always think about edge cases or how something could go wrong. Never gulp an exception. Always understand what's happening and what's not. Always see if, hey, what if this information is not given, that information is not given? How would my query perform? Like here, this is a classic case where what if start date is not an integer, then the default value will be used. Default value is 0. So the worst case of that is if something is wrong because of an edge case, I'm literally going through all the rows of my table, or not all the rows of a user in a table to do a count of it. A simple way to have guardrailed this particular error was that when we do select count id from commits where author id 1 to 3 and created at greater than 0, you could have like a simple guardrail, even though you would have not handled greater than 0 use case, right, where your start date is not given. You could have at least said at max I would have iterated through 1000 commits. So you can just apply limit 1000. So even if it is created at greater than 0, it will still only go through 1000 commits. It will not have to scan all the rows of a user in a table. So you are just trying to protect the guardrail, or you are just trying to install a guardrail that, hey, even if I see an edge case, I can protect myself, or I can limit the iterations that I want to make onto my database. Although the number would not be correct, but you can show 1000 plus commits in last week instead of showing exact number of commits in last week. That is also a possible solution. Right, so always keep yourself on your toes on whenever you're writing your query, how to structure it. Is there an edge case into this query? Can this query take down your database? In most cases, your answer would be no. That hey, how can this simple looking query take down my database? But it happens. It actually happens in real world. So always think twice before implementing it, and consider all edge cases. It's easy for me to say. That's where I said put those guardrails. That hey, at max I will only iterate through 1000 rows. Even in the edge case or even in the worst case, I wouldn't have to skim through all the rows of a table. Right. These are some basic nuances, and obviously I just took a very fictional example to help you folks understand the importance of edge cases, retries, how a database can be taken down because of an edge case, how poor SQL queries are generated. This is purely a fictional example, but just to make you folks understand the gravity of situation. At scale, things, even a small hiccup can take down your entire infrastructure. Right? Chalo, that's it. That's it for this one. I hope you found it amusing. You learned something new. If you did, if you guys again like this video, give this video a thumbs up. If you guys like the channel, give this channel a sub. I post 3 in-depth engineering videos every week, and I'll see you in the next one. Thanks a ton.